Okay, I'm live with a Rust-based demo today. I'm going to talk a little bit about a new thing that I'm working on, which is how to deploy Rust-based packages for machine learning. And really, in a nutshell, one of the things that I'm going to explore here is that Rust is actually the ideal language for large language model operations, not Python. And in fact, I already have something that I think does start to prove that scenario here. I'm going to prove out many different Rust-based examples, but in this one, what I want to do here is package PyTorch into a Rust Distroless container. Distroless is a super tiny Rust-based container. So I'm going to go ahead and take a look at this real quick. So I'm going to go ahead and say code, launch this thing, and get it cooking. So there's actually quite a bit of code in here, and I'm going to walk through each of these pieces of code and show what it does, actually demo it, and kind of go from there. So the first thing here to remember is that the goal here is to package the binary with the container itself, which is part of the tricky thing to do. So I have RTorch dist here, and what I've done is I've created a lib, a logic, a main, and a routes, right? So these are the four pieces of my code. And then I also have cargo to ML here. So you can see here, I've got quite a few dependencies. Some of these I could probably rip out and change a little bit, but in a nutshell, I'm using the PyTorch bindings. I'm using Actix as well, which is at one point was the fastest web framework on planet Earth. And I'm also using some other tools that help me build things. The other thing that I've got cooking here as well is a Docker file. Let's go ahead and take a look at this Docker file and see what we care about here. So first up, I'm using Rust as a build environment. So really, I get Rust cooking first inside of here, and then I do a curl command that curls down the PyTorch version 2. Now, next, what I do is I set the libtorch environmental variable. I copy all of the Rust code inside of this environment, and then I go through here and I build out a release. So with Rust, the idea here is you build out a release that has the binary, and I also want to put the path to this model as well, because I'm going to need that model as well. And then here I use Distroless, which is a small shrunken environment here that is going to allow us to have the smallest, tiniest footprint. And then I copy these artifacts inside of that image. And then finally, I set these environmental variables, which is the LD library path, also set model path. And then at this point, I can start Actix web server. So really what's happening is I'm taking the binary, I'm taking the model, I'm taking a couple other files like this image file, and I'm copying them into the smallest possible container that you can run. Now, in terms of the code here, first up, let's look at the main here, tiny, right? Which is the way you want it. All this thing does is invoke the beginning of the web service. Inside of here, you can see I've using some other files here, logic and routes. But basically, I have a check image prediction, I have a check image upload, and I have a check PyTorch CPU. So what these all do is really allow me to do a integrity check. So I want to make sure that I can upload images. I want to make sure that I can do predictions. I want to make sure that PyTorch itself is running. And once I've got all that going, then I can run, let's say, a smoke test. Then in terms of the library here, all this does is expose this so it's easy to test. And then I have the logic, which does all the heavy lifting. So in terms of this thing here, we have something that allows me to save files. I also have something that, again, allows me to do a self-check of prediction. I also have another piece of code here that allows me to verify that an image exists. I have the predict image here, which is actually not too bad. And then finally, at the bottom here, I also have just checking TensorFlow, make sure that it works properly. Now, in terms of the routes here, these are where the web service is ready to go. And we have a index here. I have a predict route. I also have a check image upload route. And then I have a check PyTorch CPU route. And then I have a check image prediction routes, right? So I've got all these routes all set up. We're good to go. Now, all I need to do to run it, it's actually pretty straightforward, is I can build the software. So let's go ahead and do this, which is, I think, a good thing to be aware of is that you can build your project by doing -J16. In this case, I have a 16 core machine. I want to use all of the cores, right? We can actually compile this thing and actually saturate all the cores, which is exactly what you want. And additionally, if we go through here and I open up another window, we can take a look and see this thing cooking. So you can see it's saturating all the cores here while I compile, which is awesome because it allows me to build a larger project here a lot more quickly, which is one of the advantages of using a language like Rust that's compiled, is that it's able to take advantage of a really big machine. You can just say, hey, compile the software using all the cores, and it should run a lot faster, which is awesome. So here we go. Now does it run? And once it builds, that's the hard part. All I need to do then is just go ahead and say cargo run. So let's go ahead and let this thing. It's getting to the final steps here of building. And once it builds, all it will need to do is just say cargo run. Now, one thing I'll point out here is that I like to do this, which is make run, where I give it some other commands like let's set the logging level, let's enable backtrace so that I can see if there's an error, I can help debug it. So this is something you may want to consider as well, as is actually stacking together some other commands that help you get this thing cooking. So let's go ahead and do this. Let's let this thing finish building, and then at the once it's done, we'll just go ahead and do a make run. Now, again, what's nice about this is that because I'm doing the cargo build, whatever parts are parallelizable, it'll actually use all the cores on the machine. So it looks like it's almost done here. It's just the last steps, and then we can go ahead and run this thing. Once it's cooking, I should just be able to do make run. So it can take a little bit of time to compile a large project like this because it is building quite a bit of stuff: PyTorch, C++ bindings, a web service. It's doing image prediction, image uploading, all kinds of stuff is incorporated into this project. But let's go ahead and let this thing finish. Now, of course, another thing we could do in the future as well is probably tweak the cargo file and find out what we're not actually using. Let's go ahead and do a make run. Let's get this thing going. You can see it already compiled, so it should be much more simple to get this thing running because there's not much left to do. So it's doing the final steps here, doing cargo run, and this thing will be ready to go. Now, while this is running, the other thing I'll show over here is that I do have something called smoke tests. And this is a good idea for building a microservice, is that you just go through and you write some tests for each of the things that the code is doing. Now, look, here we go, open browser. If I just go ahead and open this, we can see that I can refresh, and it even tells me, hey, run this command to do whatever it is you need to do. So, but I'm going to just run this smoke test. So I'm going to go ahead and do this. Do smoke test. Whoops, let's go into PyTorch this smoke test. And it's going to go ahead and run each of these commands here. And you can see that they all were successful. And all of the logging also shows up here as well, which is really nice, right? And it's nice to be able to go into this when you're developing, make sure that everything is cooking by running a smoke test while it's running. So that's it. That's all really you need to do to get a PyTorch system running inside of this Actix environment. The only other thing that we can do, we could also do a Docker build as well. And so if we go ahead and we look at the make file, you can see here that I've already got it set up. I can just say make tbuild, which should do nothing because it's already built. In this case, it looks like maybe it does have to actually get built again. But in a nutshell, when it's done, we can actually do a Docker image here. We can say Docker image ls, and we can see that the image it was created was 3 gigs. So even with a very large model inside, and also the ability to put all this in one spot, it's a reasonably sized image. And then in order to run it, we can just say make cp run like this, and that will actually run it just like a binary. And look, the same thing happens. We see this thing's working. All I need to do is go ahead and say smoke test, and the same thing works. So in a nutshell, I think this is a reasonable project for testing whether you can build microservices inside of the Rust environment, and also packaging PyTorch inside. And it looks like we're successful. So I'm going to end it for today.